Forget everything you've seen in the movies. Asteroid mining? It's not science fiction anymore. We are literally standing on the brink of a brand new industrial revolution. It's a gold rush, for sure, but the frontier isn't out west. It's among the stars. Okay, let's dive into what this really means.
To get a handle on the sheer scale of what we're talking about, just look at this number, 10,000 quadrillion dollars. That's the estimated value of the metals inside one single asteroid, a big M-type called 16 Psyche. I mean, that's not just more than the global economy. It's an almost incomprehensibly vast amount of wealth.
And this quote just nails it, right? For all of human history, we've been scratching the surface of just one tiny planet. Now, we're on the verge of tapping into a reserve of materials that completely dwarfs everything we have ever known. This isn't just about supplementing our economy, it's about a complete transformation.
But, just like any gold rush, you can't just head out with a pickaxe and hope for the best. The first step, the most important one, is prospecting. You have to know what you're looking for, and you definitely have to know where to find it in all that emptiness.
So here's the key thing to understand. Not all asteroids are created equal. Prospectors are basically hunting for three kinds of claims. First up, you've got your C-types. Think of these as the water tankers of the solar system, loaded with H2O. Then there are the S-types, the stony ones. These are your cosmic hardware stores, full of basic building materials like nickel and iron. And then you have the M-types, the metallic ones. These are the jackpot, the treasure chests. They're basically giant chunks of metal, packed with platinum, gold, and other precious stuff.
Okay, so you found your claim. You've pinpointed the perfect asteroid. Now what? Well, now comes the really hard part, the central engineering challenge of this whole thing. How on earth do you mine something when there's basically no gravity?
No, really, think about it for a second. On Earth, we use the massive weight of our machines to force a drill into the ground. It's called weight on bit. But in microgravity, if you try to push a drill against an asteroid, you don't go into the rock, you just push yourself away, floating off into space. It's a huge problem.
So the solution is you have to anchor yourself first. What you're looking at here is a prototype drill designed to solve exactly that problem. It has to literally bolt itself onto the asteroid's surface before it can even begin to drill. Without that anchor, the whole mission is, well, pointless.
And the ways engineers are thinking of getting a grip are just incredible. I mean, we're talking about firing actual harpoons into the surface, screwing in these giant augers, using micro-spine tech that grips like a gecko's foot, or even just burrowing the entire machine right into the loose surface material to hold on tight.
And that brings us to the next big leap. This here is the TRIDENT rover, a prototype for doing this all autonomously. Because let's be honest, these are complex, dangerous jobs. The future of mining in space is going to rely on smart robots that can handle these missions with very little input from humans back on Earth.
But what if you could skip the whole drilling and anchoring problem entirely? That's the wild idea behind optical mining. You use huge mirrors to focus sunlight into a razor-thin, intense beam. It's like a giant magnifying glass. This beam flash heats the rock, causing it to crack and instantly releasing any trapped water as vapor, which you can then just collect. No contact necessary. It's brilliant.
So, this brings us to the first big prize of this whole interstellar gold rush. And surprisingly, it's not gold, it's not platinum, it's something we have so much of here on Earth, we don't even think twice about it.
$40,000. That is roughly the cost to launch 1 single liter of water from Earth's surface into orbit. The energy it takes to escape our planet's gravity is just immense. That makes water that's already in space, locked up in those C-type asteroids, more valuable than gold.
And here's why that water is the first real treasure. The process is actually pretty simple chemistry. You take the water ice from an asteroid, you use solar panels to run electricity through it, that's electrolysis, and it splits the H2O into hydrogen and oxygen. Put those two back together, and what do you get? The most powerful chemical rocket propellant we have.
And this is the real game changer. Water becomes the oil of space. By harvesting it from asteroids, we can build in-space gas stations. This is the key that unlocks the entire solar system. Suddenly, a mission to Mars doesn't have to launch with every drop of fuel it'll ever need. It can refuel along the way. This chart lays out the whole ecosystem perfectly. That asteroid water isn't just for rocket fuel. The oxygen gets used for life support for astronauts. The water itself is great for radiation shielding. It's the cornerstone for building everything from long-term science missions to permanent off-world habitats.
Okay, so we've covered the oil of space. Now let's talk about the second payout, the one that gets all the flashy headlines. This is about the incredible metallic wealth that could either be brought back to Earth or, even more excitingly, used to start building massive new structures in space.
To give you some perspective, back here on Earth, even in the very best platinum mines, you're lucky to get ore that's about 5 to 10 parts per million platinum. On some of these metallic asteroids, the estimates are up to 100 parts per million. It's just insanely rich.
And this isn't just some abstract idea. Companies are already running the numbers on real targets. This table shows you the top 5 most cost-effective asteroids that we know of right now. These are the claims that prospectors are actually looking at today, with potential profits already worked out in the billions.
So this opens up 2 incredible paths. Path 1, bring the super valuable metals, like platinum, back to Earth. Path 2, which might be even bigger, use the abundant iron and nickel that's already up there as raw material to 3D print things in orbit. Satellite parts, new spacecraft, even sections of a space station.
So when you pull all of these threads together, you really start to get a clear picture of what this new frontier actually means for the future of humanity out there in the solar system. And that's the real takeaway here. This interstellar gold rush isn't just a resource grab. It's the very first step toward building a true spacefaring civilization. It's about creating the infrastructure, the gas stations, the foundries, the factories that will let us stop just visiting space and actually start living there.
And that really leaves us with one last massive question. For the first time in our history, we are on the cusp of having access to nearly unlimited resources and energy. So the question is no longer can we expand into the solar system. The question now is, what kind of civilization are we going to choose to build when we get there?